Okay. So I'm clearly not Ed, but in the interest of time, we swapped the slots around, so I'm proceeding basically with the next item on the agenda. Why does this keep on showing up? Hopefully this should be good enough. So first, introduction. At Cisco, we have a solution we're focusing on, and it's actually been made available to a number of customers. And in the scope of the solution, it's an NFV solution based around an OpenStack, highly available cluster. It's meant to be all of it's highly available. So the ODL controller in there will also eventually be there. We didn't quite get to it at this moment, but nevertheless, the solution is for NFV, and as I said, high availability is the key. And the scope of our testing and usage was really around functionality and then verifying that it performs and scales to the requirements for this NFV solution. Now, most of the stuff I'll be talking about here in this presentation will be around the functionality experiences that we've had. And only a subset of those, because I'm here just to focus on a couple of key problems, I think, that require attention from the community. And it's not just this community, but also the OpenStack community that likely needs to address. And things like performance and scale and those type of numbers, they're not part of this presentation. Probably I'll have a follow-on one on those. We've done the testing using Icehouse. We've been progressing to Junos. The findings are, to Juno. The findings are, well, at least so far the same. Of course, in this area and other areas, they're slightly different, but well, for the scope of this discussion, actually doesn't matter which of these two got used. Okay, so the first observation to the uninitiated is that really, well, the Neutron OpenDaylight ML2 driver is evidently very, very single-threaded. And it just likes to block waiting for OpenDaylight. So basically, that's the gating function or performance gating aspect of the whole solution. Yes.
But that's only when you're trying to set it up, not during the operations.
During the operations, it blocks. Basically, any clients, a client asking for Neutron, it's it has to go. I mean, the database commit is of course unblocked, so the Neutron database does commit everything, but there's the post commit when it reaches out to OpenDaylight when it blocks, and really nothing can progress until it responds. So, well, it's an issue now. Perhaps not so much for rarely occurring messages or events like network or subnets, but clearly for ports, it's much more of an issue. Now, we've actually said, okay, well, our Neutron cluster will solve this issue because we'll be either stateless, we'll load balance, and that's where we've come to the meat of most of the issues that we have uncovered around concurrency and race conditions. First of all, synchronization. So the driver has a very rough way of synchronizing Neutron and OpenDaylight state. And there are issues with this. Basically, within the driver, there's something called a full synchronization. And this happens typically when there's either an error or when one of the Neutron servers starts up. So what I'm showing here is exactly the sequence of events that leads to issues around this sync mechanism. So we have a T1, a Neutron event that triggers a full synchronization, meaning every single item in the Neutron database is attempting to be synchronized into OpenDaylight. Clearly, that process will take the copy of the Neutron database precisely at that given moment in time. There's no Neutron database locking. At time T2 arrives another message at a different node to delete network A. And, well, this is a very simple request. It just goes straight into ODL. And, well, it gets deleted in ODL. But it's only at time T4 that the first Neutron server actually reaches that place in the database where, oh, it finds net A, I have it in my net copy, it's not in ODL, I'll just push it back in. So, well, the end state is that Neutron looks very clean. Everything looks intended because, yeah, the database is super. Unfortunately, on ODL, you've got this network A that shouldn't be there. It doesn't matter for networks, but it matters probably more for ports. You've got lots of stale ports. So over time, basically, there's an accumulation of these events. And it gets worse if there are errors that lead to this full sync to be redone multiple times, or especially if one Neutron node restarts. As I said, it's done at every restart, after every restart. So the full sync is a problem. We have, let's say, worked a couple of solutions on this, but it's of course up to the community to probably come up with a comprehensive solution. Our strategy was to enhance the ML2 driver to minimize the number of full syncs we do. So basically, if possible, do not do a full sync so as to minimize the amount of data that needs to be transferred. Now, another interesting aspect of the sync mechanism is that, well, when it was whoever designed it, designed it in such a way that it's only triggered by the full sync is only triggered, is entered as basically a flag set after an error occurs, but the full sync actually happens only at the next run. And the next run is only triggered by the next event. So you get these weird effects, as I'm showing here, that, for example, there's a T1 that creates subnet Y on network A. And let's assume for the initial conditions that network A is in the Neutron database, so that state is good, but it's not in ODL. So ODL is out of state, out of sync. So clearly, create subnet Y, network A, on network A should fail. And it does at T2, or more or less there, because ODL doesn't have that. At that moment in time, Neutron server 2 will say, okay, we're out of sync. I will set the flag and wait for the next run to synchronize things. Well, what does a user or a client typically do is, okay, it didn't work once, let me try it a second time. Because it probably, it must have synced, it must maybe a temporary issue. Next request comes to the next Neutron server. And the next Neutron server doesn't have this flag set. So he'll try to do exactly the same operation again and again fail. So this, to the user, it leads to basically, the workaround we've had is, try it many times. Try it 3 times and eventually it will succeed, which is not very good. So issue, again, with the sync mechanism. So those are the kind of let's say, the 2 high-level issues with the sync mechanism. And as I said, we've tried to minimize them, at least in our solution, by making as little as possible use of the full syncs. And in this case, being a little bit smarter as to what happens after an error. Basically, looking at the error type, and if, in this particular case, create subnet Y fails because of network A, what we're doing is we're saying, okay, well, maybe we should just push network A and retry. So that's basically a retry mechanism inside the driver. From a slightly different kind of chapter of our experiences comes this story. Basically, in our setup, we've been using OVS, but also another virtual switch on the compute nodes for the NFV functions. And well, one problem that you end up coming with OVS or without, or with any of the other ones, is actually how do you connect the virtual switch to the actual physical network. So I don't want to fall off here, but on the vSwitch down there, I've got those red lines which show the physical interfaces, port 0, port 1, port 2, so Ethernet 0, Ethernet 1, Ethernet 2. And you need basically somewhere in the system there needs to be a mapping of saying, this Neutron provider network maps to this particular interface, port 0, port 1. After much searching through the OVS, I guess legacy, or at the time, or maybe still current, OVSDB code inside OpenDaylight, well, we found that actually there is an extended ID that is meant to be used for this. But how do you set this ID? Well, there's no standard means. There basically has to be somebody firing up a script on that compute server. The script has to be parameterized, of course, with the given Neutron network provider name and the physical port. That script injects things into OVS, and then when OVS connects, using OVSDB, it's communicated to OpenDaylight. Clearly, this is a solution that can probably work only with OVS plus OVSDB. It certainly wasn't working for our other switch type. But actually, none of this configuration has anything to do with switches or with the switch type or with the protocol. It's just a connection of Neutron network to physical interface. So what we have done is actually we created what we call a Neutron network map as a Yang model, and basically have it inside OpenDaylight. And it becomes, through Yang, becomes automatically a RESTconf API. So this information is something that can be pushed into the controller when the system is being started up, configured. And becomes independent of switch type, becomes independent of protocol, becomes something basically a Neutron configuration parameter, so to speak. And continuing on with the stories, this is also a big one. Basically, today, there is absolutely zero feedback from OpenDaylight to OpenStack regarding any rendering of errors. So yes, the state is configured, OpenDaylight and OpenStack are in sync on the database, is great, but there is actually an error in turning data into a network configuration. So to the OpenStack user, everything looks good, but actually things are very bad. So I mean, there's no connectivity. You've got to do full stack almost troubleshooting to determine what's happening. Things are particularly bad, I would say, with the OVS because of the way the Nova agent is responsible for plugging the machine into the OVS switch. And that happens after Neutron completes. So Neutron can complete, everything that is in Neutron state looks good, and it's only at that moment in time that Nova agent goes onto the host, fires up or configures whatever needs to be fired up for libvirt to be done, and attaches the VM port into BRNs of the OVS switch. So if any of those last steps fails, you've got this situation that Neutron tells you network is good, but actually it's not good at all. So we don't have so to us, the solution here would actually be, there's something wrong with this model that instead of the compute agent plugging in the VM into the network switch, it should be the network switch plugging in the VM. So basically, the network component doing the full end of the networking configuration, as opposed to having the compute agent do, let's say, a little piece of it. But yeah, other than that, there's really no solution as such, because everything happens based on the actions, successful actions of this agent. So these are the collected observations. My intent here was really just to convey the problem. Solutions, I mentioned a few. I can discuss some of them in more detail. But it's quite evident that at least there's no single solution to all of these problems. They require different approaches. And it's a little bit of our experience with it was that we've found a solution in one space, and it uncovered another issue somewhere else. And then we tackled that one, and it uncovered some issue somewhere else that we didn't expect. So it's a tricky setup to solve, and clearly I think it requires changes both on the Neutron ML2 driver, as well as on the Neutron northbound in OpenDaylight. Right, so that's all from me on this one. I don't know how we want. Well, maybe now is the time. I see Ed there, in the back of the room. I've been using your time, so you've got more because I have the follow-on session. I mean, to us, this is something that all of these issues will become apparent to anybody who tries Neutron at scale, especially in this clustering setup. I didn't mention the fact that the ODL controller, if you try clustering that, there are other issues. We didn't do that because of lack of, I mean, HA was the focus here, and we didn't have HA for OpenFlow and netconf. So it's a composite problem, but
So what mechanisms are currently available to debug when something goes wrong?
well, there's the telephone and the bridge, and lots of guys all over the world.
So what was the question?
Sorry, the question: what mechanisms are there to debug these things?
Horrible. I speak here from Wojciech's bitter experience, because it's usually me having that bitter experience when he does this. But the problem is you have a number of Neutron servers, which is, typically high, often distributed. One of them has decided it fails to communicate with OpenDaylight, and thinks it needs to resync at some point in the distant future, and all of the others are quite happily communicating away. So the answer is, one of your servers somewhere failed. If you're really lucky, it puts a log. If you've got a distributed system, that log is probably on one of the hosts that you've got to find the host, or if you've planned ahead, obviously you're centralizing the logs. But yeah, it's horrible. It really is horrible.
Yeah, and it's also it's a certain skill also to have look for the needle in the Neutron logs, right? So you gotta have or ODL logs for that matter. Yes, of course you've got to enable the ODL logs first of all. So yeah.
Do we have any set of recommended practices, like, look for these things when something goes wrong?
Some of them. I mentioned some telltale signs here, like for this, for this particular problem, everything looks good from Neutron. Actually, everything looks good from ODL, but things may look bad in Nova, right? So hey, you're doing network troubleshooting, but you got to look into Nova for perhaps some error there, or ultimately, you can look at it from the OVSDB perspective, that basically maybe the ports didn't show up in OVSDB as it should have. So that is the thing. Now, OVSDB troubleshooting, there's lots of data in OVSDB, so it's again, you have to know what you're looking for. But still, filtering on the port ID, UUID is useful. Right.
I think it might be helpful to talk about each issue at a time, because and then there are many issues.
So, I mean, if I were, from my perspective, and I'd like to point out I'm not the OpenDaylight guy in this, I'm the OpenStack guy in this, but from my perspective.
Yeah, he's the other stack.
We don't know. But having tried this, then what it feels like is a bit of a problem of a division of responsibilities. should just say, right, I've stored that. That's all it ever gets to say. I've stored that, we're all good.
And then that's like the model, right? In general.
Well,
And that's where you kind of
so that works except for the cases where you're a little bit out of sync, like
Yes, you can, that reduces the number of times you get out of sync.
like this case.
Yeah, Wojciech's bugs in OpenDaylight can be thought of lots of ways. So we got to find out more than we thought we would otherwise have seen. But this is going to happen even just intermittent network problems or either side going down or getting reset will still leave you in a funny state.
Yeah.
the good news is it's just software. We can fix it, and we actually know how to fix it. And it's all issues.
Right, so shall we just, you'll be done next week? Will that
I mean, before we dive into that, and I think most of these issues, and I apologize if I didn't, wasn't in the room right at the beginning of the presentation, stem from the fact that the driver that was written to integrate Neutron and OpenDaylight has been in a POC state for a while. So even though the two platforms have the building blocks for you to have this thing operationally work well in a scale-out environment, effectively bringing together as unveiled, these types of concerns. And I think the first step would be to document those, because if we, for instance, go and look at the management tools that we use to track certain issues, we have no tracking record of what you described. And this is a great amount of work, but we need to, first step would be to make sure that whoever is involved in OpenDaylight and Neutron and is has a vested interest in making two platforms work well together, have awareness. These guys need to have the same awareness, they need to be on the same page so that we don't duplicate it. So for instance, Flavio and I have been talking about some of these issues. I am, as much at fault as anyone else not documenting those myself. If you've done this and it seems like you've taken time to do so.
I would like to add something because this was an issue, especially the full sync issue. I encountered it last year. I went to the Barcelona context site. It has been there for a long time actually. It has been there. The date shows 18 September 2021.
Right, okay. So that
This sync bug has been documented.
see, when it comes to open source, you gotta keep persevere, trying to draw attention to whoever thinks push the boat along. Just finding a bug and forgetting about it is not gonna get the job done. So, unfortunately, that's the reality. So, first step is to find the bug, try to be as extensive in providing input and feedback as much as you can, but then trying to shepherd the issue all the way through to fix the least. If we just find a bug and forget about it, that's just gonna rot, and the launchpad is gonna
Another part that happened at the time, it was part of coordinator. I raised a lot over there.
well, I'm not telling you that. What I'm saying is that you gotta handle the issue all the way to completion.
So I think this. There's still a little bit of a problem because logging these issues against ML2 driver, who's got a certain community, I guess ever smaller because it's of the fact that the project is off somewhere in the woods, right? So at the moment, in terms of the driver, it's not along the main open stack.
What does that mean? I don't understand. What does that mean? It's its own project and doesn't need. It's not. This is a driver issue. Doesn't need to be part of the board. So I'm not sure what the.
Well, the community I'm saying is a subset of the OpenStack community. It's even a subset of the Neutron community, and I think crucially, it doesn't take into consideration the OpenDaylight community, right? So there needs to be the issue needs to be recognized on both sides, which is.
To redirect the issue to the people who care about it, right? So the one way that we tried to address this problem in Neutron was to again splitting up Neutron so that we had smaller groups better focused. And the idea is that if you raise the issue against the networking ODL project, that would draw attention from the folks who care about that, rather than getting that lost within the whole huge stockpile of issues that affect the Neutron project as a whole. Right, so that was the idea. So I think it would be beneficial to target the issue to the networking ODL project rather than Neutron as the whole platform. So I'm not sure whether
Right.
This is
And that's what I'm. Yeah. Exactly.
DL.
Well, as a matter of fact, the members of, so for instance, the reviewers of that project, board and whatnot, are people who work on either side of it. So for instance, like we have Ryan, there's Flavio, there's Kyle, there's me, there's Swami. We don't, I mean, unfortunately, we don't have people who perhaps devote 100% of their time on one or the other, like maybe like they do like 50-50 or like 80-20 or, but definitely we need, we need more help. And again,
Folks
being,
like Isaac, I just want to point him out, is an OpenStack guy as far as I'm concerned, who's here, sitting right there. So don't think this is the beginning.
Yeah,
This is
sure.
nothing but.
Well, I mean, in particular, we've got a lot of interesting things we've gone through. We've done good work in trying to get something going, and have shaken a whole bunch of interesting things out. And Armando was fabulously helpful in turning some things out. We have to sort of ask ourselves questions like, is this the communication protocol that we want to? Is this communication protocol going to meet our needs going between OpenStack and OpenDaylight going forward, right? And historically, we've been very fond of the way that we have OpenStack communicate to OpenDaylight. It's bought us a lot. And so if you're going to say, okay, for reasons having to do with HA, with scalability, with error reporting, if we need to move in a different direction, then you sort of take a step back and say, okay, what is it about this way that we've been communicating that we really care about? Because it's a very human thing to sort of say, okay, I care about X, but you don't really care about X, you care about Y. X is just standing in for it, right? Very human. And we've also done some things like we've done it as an ML2 driver, right? So there's an open question. Do we want to continue to be an ML2 driver, or do we want to become a plugin? Interesting question. Don't want to bias the answer either way, but it's something that people have brought up. There have been questions about, like, do you want to continue to do this REST pass-through? If so, how are you going to manage the synchronization if you've got multiple control nodes? Because one of the problems right now is that if you simply dump state when a control node comes up, you're going to have difficulties. And particularly in environments with multiple control nodes. So how do you manage that state? I'm not aware of, and you may know differently, Armando, is there any kind of way to know, is there any serialization indexes, state counters, et cetera, that can be used to determine, okay, state is moved and I haven't found out about it? Or is it just,
but the point is,
there's
you know,
common
unless,
distributed system now?
unless we start documenting this thing so that when we go home, because we are pretty much show distributed, right? We start documenting these things and we take ownership and say, an action item and say, okay, I'm gonna document this stuff. And then when we go home, we start, planning on who does what. And effectively, these get translated in, simple bug fixes or major blueprint work. And I personally, when I start looking at the ML2 driver for OpenDaylight, I realized that yes, the driver itself was designed and implemented, making certain assumptions that are not necessarily true in production environments when you have multiple input servers, multiple OpenDaylight controllers, and what happens when you're building failures. So we may need to rethink some design decisions that were made. One that you mentioned was, for instance, whether we want to focus on ML2 versus an analytic driver, even though that probably steer attention away from the real problem, because these distributed system issues exist regardless of whether you choose ML2 versus a monolithic plugin. But the idea is that, okay, let's acknowledge and document for those first, and so that we can collaborate in a distributed fashion in an effective way, because we're meeting only 6 months, face-to-face, only every 6 months. We can't just wait for face-to-face meeting to discuss about these things. So we gotta enable ourselves to work remotely and asynchronously by leveraging the tools that help us to obviously drive the agenda on a weekly basis. IRC, Launchpad, or whatever.
So really, really quickly, okay, just a quick show of hands. How many folks would actually be willing to pick up a shovel and do some work here, either on the OpenStack side or the OpenDaylight side? Right? That is fabulous. I love you guys. Fly your tickets. So that's awesome. Like, we have people who are willing to do
So there is one.
Discouraged, too tired out. And you can't tell everything is. That's how I
We drew the easy problem.
So while most of the discussion, focuses rightly on the ML2, there is one actually aspect which. Oh, sorry.
So just to throw ideas into the picture that so once we move OpenDaylight to open for Switch to be the main data path of the Neutron, okay? So three challenges come into play, like at some point we need to stop the flooding and make OpenDaylight configure the forwarding correctly, okay? Such that, let's say, unknowns, ops will be handled by OpenDaylight,
There's actually good news on that front.
which is good. And then you introduce like the scalability problems, like when it needs a lot of OpenDaylight instances to when the OpenStack scales. Then the next level, like what we talked today, is moving in a logging feed. It's in a carrier environment, but we have multiple feeds. We need to allow connection between different feeds on the same layer 2 connections and the same VPN connections to connect to each other. So we need some kind of mapping between this network to the other network with multiple VIMs. That needs to be scaled to the next level. How you do that between different VIMs and between different clusters of OpenDaylight, how you do federation. So things needs to get to I agree we first need to solve the basic stuff of synchronization and the failures, but there are other steps into it.
So while most of the discussion fairly focused, I think, on this ML2, ODL kind of boundary, there are two aspects on these observations and at least these findings. That one of which focuses or addressed directly to the ODL community and it can be addressed by the ODL community, and the one only by the OpenStack community. I'll start with the OpenDaylight one. This network map, right? This is something that I've been, kind of discussing and proposing out on the alias. I think it's very useful to have this in a, from a control perspective, we can discuss the details, but at least the reaction from the email alias was that it's declared out of scope from the project because it has nothing to do with the Neutron API itself.
Well, I'm not sure whether I agree with that 100% because we had that mapping on the agent's configuration files for the OBS keys, right? So we do map the bridge to the physical network statically in a config file. It sucks. And we've been talking about how we can move away from that, which means perhaps exposing an API endpoint and an API to Neutron server so that an admin can create a mapping and store the mapping in the DB, in which case the OpenDaylight can leverage that. Now, if you can celebrate on either side of the fence, right? And both may have pros and cons. We can have a discussion about that.
I mean, I'm thinking, since ODL is the network controller in this space, and actually this problem lends itself to topology. It shows how the topology, from the Neutron network maps into the physical.
Yeah, I'm talking about where
Yeah.
where do you store all the mapping, right?
Well, so I would assert that Neutron, as an OpenStack, doesn't need this information. And that's why it doesn't have it, is because it ended up. No, it doesn't need it. Yes. It doesn't have it in its database, and because it never needed it.
It exists in certain backends.
But it is absolutely essential. Yes. It is absolutely essential. This information is absolutely essential to correctly configure the network. So I think this information belongs to whoever is configuring the network.
My point is that up until now, we didn't have the need of exposing the information to the API and store it in the database because only one backend really needed to have that mapping. But I mean, if we start thinking about having that mapping held or the need of that mapping in other backends, then we can have the discussion and decide what's best from a design standpoint, whether that mapping is stored in various backends or we bring it up so that all the backends can leverage.
So I would also add in one aspect here, which is the backend you're referring to here is currently